So we're solving spring exam 2. The first question says, this is our first question. In a study of migrating sandhill cranes, the distances traveled in a day were normally distributed with a mean of 267 kilometers and standard deviation of 86. Okay, so what is 267? What is 86? What are these numbers?
The mean and standard deviation.
For the population or for the sample?
Population.
Population in a study. Very good. So let me write this information on the board, then I share it with you. Mean is 267 and standard deviation is 86. Perfect. Question says, find the probability that the distance traveled in a day by a randomly selected sandhill crane from the study is less than 200. So less than 200. B, find the probability that it's in between 250, 350.
Professor, I think we're in PDF, so.
And C, greater than 500. Okay, I wrote this information on the board. Let me share the board with you. Okay, it says the probability that X is less than 200. We can directly use our calculator. We don't have to convert that into Z. But usually statisticians convert these numbers into Z values to keep the privacy of the data. We can use our normal CDF. The lower limit is a very small number. You can write negative 1,000, and upper limit for this case is going to be 200. Mean is 267, and the standard deviation is 86. Let us use our calculator. So let us turn on the calculator. Second, Mars. Normal CDF. The lower limit is negative 1,000, 10,000. Upper limit is 200. Mean is 267. And standard deviation is 86. %. The second one says the lower limit is 250.
It's always use a 2 decimal.
If it's not given to you, you can leave it as 3 decimal places or 2 decimal places. That's fine. Lower limit 250, upper limit is 350, mean is the same, standard deviation is the same. Let us use our calculator. So let's clear this, second bars, normal CDF. The lower limit is now 250. The upper limit is 350. Mean and standard deviation are the same. So enter. It's almost 41%. So almost 41%. Part C says your lower limit is 500, 500 and above. So your lower limit is 500. Your upper limit is positive 1,000, positive 10,000, mean the same, standard deviation the same. Now let us use our calculator. Second, bars, normal CDF, 500. It goes to a very large number like 1,000. Mean stays the same, standard deviation stays the same. So we get almost, very bad, we get a very small number, 0.003. Almost 0.003. There you go. Let's take a look at the next question. This question is similar to what we did in class. This is similar to one of our examples. So it says the figure at the right is from a survey of 498. So what is 498?
Sample.
And
Sample mean, excellent. Sample size. Very good. Question 2, the sample size is given to you, which is 498. Question says, construct a 90% confidence interval. What is 90%?
C.
Which is level of
Confidence.
confidence. Level of confidence. For the population proportion. Guys, when you read a question, quickly identify the estimate. Is it a mean? Is it proportion? Is it standard deviation? What it is? Of US adults who think that teenagers are the more dangerous drivers. Well, teenagers, do we have a point estimate? Yes, our point estimate is 71%. P hat is 71%. So what are the steps in constructing a confidence interval? What's the first step? N is greater than equals to 30, or population is normally distributed, but this is when you're using mean. Am I right? What about the proportion? We are working with proportion. What's the first step? Find point estimate, which is, we already found it, 71%. And very good, thank you so much. The second step is check to see if NP hat is greater than equals to 5. and NQ hat is greater than equals to 5, or normality is met. N is 498, P hat is 71% greater than 5, and N 498 times Q hat. Remember, Q hat is 1 minus P hat, which is 29% greater than 5. We're both happy about this. Next step, find level of confidence, which is 90%. So now we can move on to find critical value, ZC. To find critical value, you can use your calculator. C is 90%, so we need inverse norm. 1 minus C divided by 2. Inverse norm, 1 minus C, 1 minus 90%, 10%, divided by 2 is 5%. Okay, let's turn on the calculator. And here we go to second bars. We need inverse norm. Inverse norm, okay. What's the area? 5%. Mean is 0. Standard deviation is 0 because we're finding our ZC, Z value. So paste. Negative 1.645. But since we are using ZC to find the margin of error, we have to use the positive one. 1.645. Next, define margin of
Error.
error. Excellent. E is equal to ZC times square root of P hat Q hat over N. Guys, it's not the mean. We cannot use the formula having standard deviation in it. We have to use the formula with P hat and Q hat in it. So E, or margin of error, is 1.645 times square root of P hat is equal to 45%. I'm sorry, 71 times Q hat, 29%, divided by N, which is 498. So what is the margin of error that you have? What is that approximately?
0.03.
0.03. This is your margin of error. Now you can construct your confidence interval, which is P hat minus E, P hat plus E. 71% minus 3%, and 71% plus 3%.
0.678.
And 0.74. So we have 9%.
I use calculator and something is I use a 3 decimal.
That's okay. That's absolutely fine. So question 3, it says, hey, you randomly select 16 coffee shops. So let me write down the information on the board. 16 coffee shops. And measure the temperature of coffee sold at each. The sample mean temperature, very well, guys. Here you have mean. Your sample mean temperature is 162. So X bar is given to you, 162. With a sample standard deviation, so S is given to you, 10. Construct a 95% confidence interval for the population mean temperature of coffee sold. And hopefully we have this information. We were waiting for this information. It's normally distributed because the sample size is small. 95%. So C is 95%. Remember that. For previous question, we didn't have the mean. We had proportion. That's why our formula was different. So let me write this down next to this so you know we are using a different steps. So this is for question 2. Now we moved on to question 3. We're constructing a confidence interval. What's the first step? Step 1. N is greater than equals to 30 or population is normal. Is N greater than equals to 30?
No.
But population is normal. We know about that. Step 2. Point estimate. It's given to us, 162. Next step. Next step. Hello?
Find ZC.
Very good. So what is your C confidence level? 95%. What is ZC? We can use our calculator to find ZC. So C is 95%. Inverse norm for 1 minus C divided by 2. So inverse norm, 1 minus 95% is 5%, divided by 2 is 0.025. So ZC, let's use our calculator. Second, Mars, inverse norm, 0.025, mean is 0, standard deviation is 1. And here we're waiting for our ZC. ZC, here is given as negative number, so you can copy down the negative number on the left-hand side, 1.96. But when we're using our margin of error, we ignore this negative sign. 1.96. Well, next step, margin of error, which is ZC times
Standard deviation over square root of n.
very good. Sigma over square root of n. So margin of error 1.96. Sigma. What is sigma? Do we have sigma?
10.
Do we have sigma?
No sigma.
No sigma. So
We have to use
use
sigma s and then equal to s a standard deviation and divide the square n.
are we using ZC?
No.
No. What are we using?
TC.
TC. Yes. TC. TC. We cannot use this formula. We have to use a formula with TC in it. It's not the formula that you're going to use. It is TC times S over square root of n. Sigma is not given to us. What's given? The sample standard deviation. So to find TC, what are we going to use? I'm waiting on you guys.
T-distribution table.
Very good. So what is on the left-hand side?
Degrees of freedom.
Degrees of freedom, which is equal to, in this case,
15.
15. 16 minus 1, 15. And C is 95%. The intersection is your critical value, TC. What is your TC?
But we can use calculator, right?
No, you can use your T table.
2.131.
2.131. So my TC is 2.131. So note that if you were used your ZC, your critical value was smaller. Your critical value was smaller. Now that you're using your TC, you get a bigger, larger critical value. So your margin of error is going to be different. Your margin of error E is 2.131 times 10 divided by square root of 16. What's the margin of error? Approximately
5.33.
5.33. Now you can construct your confidence interval and say that, hey, confidence interval x bar minus E, x bar plus E. X bar is 162 minus 5.33 and 162 plus 5.33. So let me see, 167.33. And here, if you do the subtraction, what do you get?
156.67.
67. Thank you so much. This is your confidence interval. So we are 95% confident that the temperature of coffee salt is in between 156.67 degrees to 167.33 degrees. So question 4, area. You have a survey of 2,383 US adults. 1,073 of them think that there should be more government regulation of oil companies. Well, first of all, find the point estimate for population proportion. B, construct a 95% confidence interval. C, find the minimum sample size to estimate population proportion of 99% confidence level in order to ensure the estimate is accurate within 3% of population proportion. So let's write this information on the board. N is given to us, 2,383. And X is also given to us, 1,073. And the level of confidence for part B is 95%. And for part C, we want to find the sample size. Then C is 99%. And margin of error is 3%. Okay, let me share the screen with you. Okay, here we go. Question 4, N is given to us, X is given to us, The level of confidence is 95%. And we want to find our confidence interval. Are we using left column or right column? Which one are we using?
Column 3.
We're using the rest of the class. We're using which one? Left, right. Is it this one or is it this one?
Right column.
Right.
Right. Excellent. Thank you very much. So, since the question is asking about proportion, they're going to use right column. What is your p hat? P hat is x divided by n, so we have to do a little bit of algebra. Your x is 1073, your n is 2383. What is this approximately?
0.45.
45%. Thank you very much. So what is your q hat then?
0.55.
Very good, 55%. So next step is to check to see if n times p hat is greater than equal to 5 and q hat is greater than equal to 5. Our n is 2383 and p hat is 0.45, 45%, of course is greater than equals to 5. And q and 2383 times 55%, it is of course greater than equals to 5. What is our level of confidence? 95%. What is our ZC?
Oh, I have a question. And when we do the exam,
So let's find our ZC. C is 95%, inverse norm, 1 minus C divided by 2, inverse norm for 0.025. ZC is negative 1.96. Again, for the margin of error, we ignore this negative sign. 1.96. Now let's find the margin of error. E is equal to 1.96 times square root of 45% times 55% divided by n. N is 2383. So what is the margin of error approximately?
0.02.
0.02. Thank you very much. Almost 2%. So the confidence interval is p hat minus e, p hat plus e. So this is question 4. So confidence interval is approximately, your p hat is 45%, so let's use approximation. 45% minus 2% and 45% plus 2%. This is approximately 43% to 47%. So part C says, what is the sample size if you want to construct a 99% confidence interval with margin of error to be 3%? So what are we doing? We're increasing the marginal error, and we want to know what is a good sample size. So the sample size in this case follows the formula n equals to p hat q hat times zc divided by e squared.
Huh?
Very well. We have our p hat, we have our q hat. Let's just plug them in. And ZC, we need to use 99%. We have our E. P hat, we already have P hat. P hat is 45%. Q hat, we already know that it's 55%. We need to find ZC. We have our E. What is ZC? To find ZC, we are using 99%. So 1 minus 99% is just 1%. You have 1% divided by 2. So we're finding inverse norm of 0.005. Let us use our calculator to find ZC. Second verse, inverse norm, 0.005. Mean is 0, standard deviation is 1. Here we go. Negative 2.50, let's write 50.576, or you can leave it as 2.58. We're using approximation, not the exact value. So your ZC, since you're using that for sample size, it must be positive. So 2.58.
I have a question.
Go ahead.
Do we have to write?
So 2.58. Well, we have all of these. Let's plug them in. P hat, 45%, 55%, ZC, 2.58 divided by margin of error is given to us 3% raised to the second power. So what is your N? What is your calculation here?
1018.24 around.
1,000?
824.
Does it have any decimal?
No, I around. The final result is that one.
Rounded up?
Yeah.
Okay, perfect. The rest of the class, what do you have? You already have one answer?
Same.
Mine is 1,831.
31, okay. 1,831. What else? Emily, the same.
Oh,
Question 5. It says, you wish to estimate with 95% confidence the population proportion of tablet owners who use their tablets daily. Your estimate must be accurate within 2% of population proportion. You don't have any information about P hat, Q hat. Find the minimum sample size. Okay. So question 5. We don't know what n is. We don't know what x is. We don't know what is our p hat. We have no idea about our q hat. Nothing is given to us. We only know that the confidence level is 95% and the margin of error is equal to, what is our margin of error? How many percent?
2%.
2%. Okay, perfect. And now it says find the minimum sample size. The minimum sample size for the proportion, we just learned that is p hat q hat times zc over e squared. I have my e, I have my c, so I can find zc. What is zc?
1.96.
I have my zc. What about p hat q hat? I don't have any.
0.5.
So we use
0.5.
50%. Excellent. So n is 50% times 50%. ZC 1.96 divided by 0.02 raised to the second power. So what is your sample size? Minimum sample size?
240, 408, 01,
200
or 01.
or 01. So you get 2,405.
But it's 1, 01.
01, 01. Thank you. The rest of the class, what do you have? $24.01, very good.
Same answer as well.
Same answer, perfect. Remember that if you use different decimal values for your ZC, your sample size will be changing. So if you use a different Z value, you get a different sample size. Next question. Very interesting question. So when a water taxi sank in Baltimore's inner harbor, an investigation revealed that the safe passenger load for the water taxi was 3,500. It was also noted that the mean weight of a passenger was assumed to be 140. Assume a worst case scenario in which all of the passengers are adult men. This could easily occur in a city that hosts conventions in which people of the same gender often travel in groups. So there is a possibility there. Assume that weights of men are normally distributed and the mean is 182.9 with standard deviation of 40.8. If one man is randomly selected, find the probability that he weighs less than 174. B, with a load limit of 3,500, how many male passengers are allowed if we assume a mean weight is 140? So for question 6, mean is given, standard deviation is also given. We're finding the probability that x is less than 174. We use normal CDF on our calculator. Lower limit is negative 1,000, like negative 10,000. Upper limit is given to us, 174. So let us use our calculator. Here we go. Second verse, normal CDF, lower limit. Okay, my lower limit is That's a good lower limit. I'm not going to change it. My upper limit is 174. Mean is 182.9. Standard deviation is 40.8. What's the probability? 41.37.
0.414.
37.
You use 4 decimal.
Yeah, that's okay. You can say that approximately it is 41%. With the load is given to you. Load 3,500. This is the maximum load. Maximum load. Maximum load is 3,500. Actually, my painting is very good, but I don't have time to paint it for you.
So it's gonna be 3,500 over 140.
Very good. It says if we assume a mean weight, if you know that the mean weight of each of, if you take these sample and find the mean weight is 140. So how many of people with weight 140 you can fit into this? You're allowed to fit into this. You just do division. 3,500 divided by 140, which is
25.
25. Okay. 25.